Hi guys, so since I'm going to be gone on Thursday, I wanted to go ahead and give you guys something to help you with the review in case you're getting stuck. So all I'm going to do is just work out the review so you guys can check any questions that you're unsure about. So these first ones, a lot of these are using that inverse property that we did on the second day. So if you remember, that was a property where if you had something like 4 to the log base 4, sorry guys, I'm having a hard time writing on here today, of, let's just say x. If you have that base and that base match, your answer is just the x. All right, so a couple of those are going to use that property. So again, that would be something like 7 to the log base 7 of 3. Your answer would just be 3. It works the same way with log. So if you have log base 2 of 2 to the x, if those match, it's just the x. So something like log base 7 of 7 to the y would be y. Log base 3 of 3 to the 12th would just be 12. So a lot of these are going to use this property. So look at this first one, okay? ln, the base is e. The e and the e match, so your answer is just 3x. On the next one, 4 to the log base 4. Those match, so everything that's over there is just 2. So this is x times 2, or 2x. Again, that same property, you've got the base and the argument match. So this first one over here is just x. The second one uses the same property, the 10 and the 10 match. So that one is just y. So your final answer is x plus y. I'm going to skip down to 6 and 7 because those are going to use that same property. So if you look, remember that 5 out in front, we have to move that first. So using your log rules, the 5 becomes the exponent. Now those bases match. So your answer is just x to the 5th. Looking at 7, the 10 and the 10 match. So even though the base isn't written, the base is 10, those match. So your answer is 2x. The other ones are a little bit different. So the first one, we'll go back to number 4. You're just evaluating this. Remember what we did was we said this equals x. Then you rewrite it in exponential form. 2 to the x equals 1. Anything to the 0 power is 1. The base, if it's not listed, is 10. So this would be 10 to the x equals 10. And anything to the first power is itself. The last one that's on there, if you tried to type this into a calculator, you would get an error because you cannot have a negative base. No negative bases and no negative arguments. So this one is just not possible. All right, so let's move on and look at some condensing properties. So remember, the first thing we do is we move the exponent, or we move the number out in front to be the exponent. And the minus doesn't move. A couple of you guys made that mistake on the quiz. So this will be b to the 1/2, and then this will be c squared. Anything that comes after a minus is going to be in the bottom of the fraction. And that's your log. Same thing on the next one. Number out in front becomes the exponent, so we move those first. Anything that comes after the minus will be at the bottom. And I'm going to go ahead and do what I should have done on the last one. Remember, x to the 1/2 means square root of x. So I'm going to rewrite that. The z will be at the top. The y squared will be at the bottom. And let me go ahead and rewrite that b one because that's the way it should look. That should be the square root of b. Because remember, 1/2 as an exponent means square root. All right, so now let's solve. So you're going to see 4 different types of solving questions here. This first one over here on the left, this one is exponential. So if it's exponential, you need to get the exponent base and its exponent by itself first, which means the first thing I need to get rid of is the minus 5. So the first thing I'm going to do is I'm going to add 5 to both sides. Now I need to get rid of the 9. Right now it's 9 times that, so I'm going to divide both sides by 9. Once you have the exponent base by itself, you're going to go from exponential form to log form. So the base of the exponent is the base of the log. So this would be log base 2. Then you flip your other two numbers. So log base 2 of 9 is equal to 3x. Then you got to get x by itself. So your last step to get x by itself would be to divide everything by 3. So log base 2 of 9 divided by 3 is your calculator ready answer. At this point, you would go ahead and type this into a calculator. So the way that you'll type this into a calculator, what you would do, you would go to, let me see if I can show it to you guys. All right, so I'm going to go, in order to type that log base, I'm going to do my fraction bar first, actually. I think that'll be easier. So the fraction bar is that button below the X. To do a log of a different base, I'm going to do math, which is F4, log AB, which is F2. Then I can do base 2 of 9, and then I can put in my denominator of 3. And then we can round that. All right, let's try the next one. So this is a log equation. So whenever you have log equations, you want to combine those two logs together using your properties. So the base doesn't change. If two logs are added, you can multiply the arguments. So 1/2 times 10 would be 5x. Now in this case, we have a log equal to a number, which means we need to rewrite this in exponential form. So to rewrite this in exponential form, it would be 3 to the third equals 5x. 3 to the third is 27. So to get x by itself, I would divide by 5. So I get 27 over 5 as my value for x. All right, let's look at two more equations, and then we'll just do two more that have a very similar style to these. So this next one is exponential, so very similar again. We're going to get the base and the exponent by itself. So get the e by itself. So to get e by itself, the first thing I'm going to do is divide by 3 on both sides. E is by itself, so now I'm going to write this in log form. So this would be log base e of 25 equals x minus 1. Now remember, we don't really write log base e, we write ln. So ln of 25 equals x minus 1. Add 1 to both sides, and remember, you cannot combine the 25 and the 1. So that is your exact answer. At that point, you would plug that into a calculator. Just make sure when you plug it in that you open parentheses after the ln, and let me show you guys that. So ln, and then you put your parentheses there, and that was the natural log of 25. And I can't remember if it was plus 1 or minus 1. I think it was plus 1. And at that point, you would go ahead and add it. All right, let's go ahead and look at another. This one is a log equation. And again, with log equations, you're typically going to try to condense using those properties wherever you can. So these two on the left, those logs are subtracted, which means you can divide the argument. So 6 divided by 2 is 3. This one is different than the previous question because instead of a log equal to a number, you have logs on both sides. So in order to solve this, we just take the arguments and set the arguments equal to each other. So to get x by itself, you would divide by 10. So I get 3 over 10. All right, these next ones, again, same thing as the previous. We're just different numbers, but similar style. So first one's exponential. Get the exponent by itself. So first step is minus 6. Next step is divide by 5. Next step, we're going to rewrite this as a log. So log, the base of the exponent's the base of the log. Flip the other 2. So log base 7 of 8. Then just solve for x. We're going to add 5. Again, we don't combine that into our log. And then we divide by 2. So there is our calculator ready answer. And again, you would plug this into your calculator just like we showed on the last one using log AB. All right, log equation. Use your log properties. Combine those together. The arguments can be multiplied. You don't change the base. This time it's log equal to a number. So let's write it in exponential form. So 4 to the second is equal to 30x. 4 squared is 16. To get x by itself, you'll divide by 30. So I get 8 over 15 is equal to x. All right, again, similar to the last two we did. And actually, I realize now the numbers are the same. I apologize. This is your second number 13 and your second number 14. But get the e by itself. So let's divide by 5. And that should be 18, I believe. Then from here, we're going to go ahead and rewrite this as a log. So when we rewrite this as a log, it's going to be log base e, which I'm going to write ln. of 18 equals 2x plus 3. Get x by itself, we'll minus 3. We don't add it to the 18. We'll divide everything by 2. There is your calculator ready answer. Plug that into your calculator to get the decimal. All right, last one. Combine the two logs on the left. They're subtracted, so I'm going to divide the arguments. So 12x divided by 3. Sorry about that, guys. So 12x divided by 3, that is just 4x. And this time you have a log equal to a log, which means that you can just set the arguments equal. So 4x equals 40, so x equals 10. All right, moving along. After that, we did graphing. So some things to remember about graphing. Exponential functions have horizontal asymptotes. Those are y equals, and you use the last number. Log has vertical asymptotes. You take what's in the parentheses, and you set it equal to x. Exponential's pivot point starts at 0, 1. Log's pivot point starts at 1, 0. And then the shape of the parent function, exponential has that shape, and log has this shape. All right, so let's go ahead and graph these. So we'll start with the transformations. This one has gone left 1 and down 3. That means my asymptote, y equals just the last number, so y equals -3. I'll go ahead and graph that first. Pivot point for exponential starts at 0, 1, so we're going to go left 1, down 3. So that is my new pivot point. My new pivot point is at -1, -2. Has the same shape because there's no reflections. Every exponential domain is -infinity to infinity. Range bottom to top. The lowest y value is -3, continues to infinity. All right, let's do log. We've got a negative on the inside. That's a reflection over the y. The +2 on the outside is a shift up 2. To find the asymptote, we take -x. We set it equal to 0. So my asymptote is x equals 0. Remember, that's a vertical line for log. Pivot point starts at 1, 0. We reflect it over the y, and then we shift it up 2. So that is my new pivot point. Shape of the parent function starts here, but if we reflect it over the y, it's going to look like that. So there is my reflection. Domain left to right, -infinity to 0. Range, -infinity to infinity. Remember, all log functions' range are -infinity to infinity. The domain will be based off the asymptote. And for all of these, domain and range, we are using parentheses. All right, exponential. So exponential, y equals for our asymptote. It's y equals the last number. Transformations, the negative out in front is a reflection over the x, and then we've gone up 2. So let me graph our asymptote first. Pivot point starts at 0, 1. So 0, 1 gets reflected over the x, then it gets shifted up 2, and it actually ends up right back where it started. So the pivot point is at 0, 1. Shape of the parent function normally is like this. We're going to reflect it over the x. Domain then is -infinity to infinity for all exponentials. Range bottom to top, -infinity to 2 with a parenthesis. All right, last one on the graphs, our log, reflection over the x, that's the negative out in front, and a shift right. To find the asymptote, we take x minus 4 and set it equal to 0. So we'll graph that first. Pivot point starts at 1, 0. We reflect it over the x, but that doesn't change it. Then we shift it right, 1, 2, 3, 4, and that is my new pivot point. The shape normally looks like this, but we're reflecting it over the x. New pivot point here is at 5, 0. Domain is from the asymptote, so from 4 to infinity. Range, -infinity to infinity. All right, last thing we're going to look at is the application questions. So remember, we have to know what these variables stand for. Some of these we have to solve algebraically. So this is our equation for compounded anything but continuous. N is the number of times it's compounded in a year. R is the rate as a decimal. A is the amount after time. P is the starting amount. So let's fill in this information. $300 is invested. That's my P value. 7%, so 0.07. Compounded quarterly, that's 4 times, so N is 4. How long? So we don't know time. Okay, and I don't know why I put an equal there. I apologize. We want to know when this will equal 1,000. So we have to solve algebraically on this one. All right, so sorry guys, it's the lunch bells. So I'm going to type 1 plus 0.07 divided by 4 into the calculator, and I'm going to rewrite this as 1.0175 to the 4x. Now, just like we did in those previous equations, I want to get the exponent base by itself. So I'm going to divide both sides by 300, which is going to be 10 over 3. Now the exponent base is by itself, so just like we did with solving, we're going to rewrite this as a log. The base of the exponent is the base of the log. The other number is the argument. Move the exponent to the other side. Last step, just divide by 4, and that is your exact calculator ready answer. So again, to plug this into your calculator, I'll go ahead and go through that with you guys. All right, so I'm going to do the fraction bar first, which again, that's the button that's below the x. I'm going to do log AB. Now, if you don't see this screen or you don't remember, I'm going to press exit just to get back to what you normally see. And I accidentally deleted my fraction bar. I'm going to do math, which is F4, log AB, which is F2. So the base is 1.0175. The argument was 10 over 3. And then I'm dividing the whole thing by 4. And that gives me my answer. Now, if you forget where log AB is, your other option, if you do shift 4, that's the catalog, then you can type L and you can scroll down until you see log AB. So that's your other option if you can't remember where it is. All right, so let's finish these up. All right, so now I want to figure out how much money there will be after 18 years. So same equation, set it up again. I don't know A, principal is 300, 1 plus 0.07 over 4 to the 4 times 18. At this point, you can just plug all of that in exactly the way it's written into run matrix. Don't plug in A, don't plug in any X's, just literally type in the 300, 1 plus 0.07 over 4 to the 4 over 18. And I'll show you guys what that should look like. All right, so this one I would do 300, open parentheses, 1 plus, I'll do the fraction bar, which is again below the X, above the 7, 0.07 divided by 4, close your parentheses. Your exponent is a little kind of triangle button that's next to exit. And then 4 times 18. And that will tell you how much money you'll have after 18 years. All right, let's do our last couple. All right, so both of these won't be solving. These will just be plugging in our values. So this is our continuously compounded interest formula. So for continuously compounded interest, we're using the PERT formula. So 15,000 is our starting amount. E is the E that's on your calculator. 2.5% is 0.025 as a decimal. 4 years is my X. And again, we can just plug this. The variable's already by itself, so just plug all that into run matrix. Remember, E is shift LN. Shift LN is how you find E. And then last one, half-life. So this is your half-life equation. P is the starting amount, A is the amount after time. Just remember the T and the H. The H is the actual half-life. The time is how long we're looking for in the problem. So on this one, the half-life of ibuprofen is 6 hours. That's H. We have 400 to start. We want to know how much we will have. And then after 8 hours, so that is my T. So my exponent would just be 8 divided by 6. And again, the variable is already by itself. Plug that straight into the calculator the way that it is written, and you will get your answer. All right, guys, so that is your review in a fast format. Hopefully this helps you guys answer any last-minute questions you may have before your test. Good luck.